As I said already, it's a derivative of GPT 3.5.
Yep.
It's got it's a combination of like an updated base of GPT-3 models such as DaVinci, and then it's got a much more fine-tuned model in the as well included in it called Instruct GPT. The main iteration to me, and I'd like your thoughts on this, Elliot, is on the training, and that seems to be like the main difference between it and GPT-3. The way that they trained it was they kind of had a three-step, and each step got increasingly less involvement by humans. The first one was very, very detailed, specific human training where they would generate prompts and then write a perfect prompt for it, multiple, and then feed that to the models to show them what it meant to write a correct prompt in this scenario. The second step in this was they then had the model create a number of responses themselves, and then they would have humans rank those in terms of correctness. They then used this in the third step to train a reward model system for it. And they use something called PPO. And Elliot, if you could jump in and explain what PPO is, that would be wonderful.
PPO is proximal policy optimization. And in the world of reinforcement learning, the policy is basically the weights or the sort of algorithmic setup that the AI is going to follow to process its environment, in this case, the text that it gets, and act accordingly. And proximal policy optimization is sort of a change to your traditional sort of policy gradient update methods, which refine one policy based on the actions and the rewards, to refining a search space. So it looks for policies that are in the sort of latent space or in the sort of high dimensional space that is a policy. It will do a local search to try and find new candidates for how it should respond. So, very likely this, and I'll be honest, I haven't read in depth how it works, but if I was to postulate, I would say that this is likely a good technique for that sort of refined, fine-grained tuning of a policy, in that, you're pretty much where you need to be, and you just need to search the neighborhood of possible outcomes based on that, rather than something that you would run from step 0 onwards, because, when you initialize your weights randomly, you're so far away from the truth that if you just sort of wander around blindly in the dark, you're very unlikely to end up where you need to be without a very strong pull in that direction.
Does this sound like to you then a speed optimization or a accuracy optimization that they're going for?
I think it's really just changing the way that we train these models in a fine-tuning type scenario. So, the typical sort of gradient descent on policies and techniques that, we're quite used to work very well to get us to that sort of 80% mark. And then these are to, pull back the speed at which we're making optimizations and, the method that we're using to get a bit more exploratory and say, look, we know we're roughly in the right area. Let's start to take a few samples around where we are, because ultimately the data is not going to pull us in the correct direction every single time, because there's so many different candidate responses for a given prompt that are just as true as one another. And what we need to do is sort of solve on average the quality of these responses, rather than have a sort of one-to-one linking between this prompt should always return this answer.